Hello, are you ready for another adventure? Great, let's start. In today's session, we're going to classify elements based on different physical properties. An element is a pure substance whose smallest particles are made up of only one kind of atom. It is also known as the simplest form of a substance. The three major classifications of elements are metal, semi-metal, and non-metal. First is metal. A metal is an element that readily forms positive ions and has metallic bonds. This is the most abundant type of element found on Earth. Here are the properties of a metal. Number 1. Luster. Luster refers to how shiny an object is. And since this is a property of metals, we can say that all metals are lustrous. One of the shiniest metals is rhodium, which is considered as the rarest and most valuable precious metal in the world. Yes, you heard it right. This precious metal actually costs more than twice the price of gold. The next property is melting point. Generally, metals do not melt easily because they require a huge amount of heat for them to undergo phase change. Tungsten, the metal with the highest melting point, requires a temperature of 3,422 degrees Celsius, well, more than half the surface temperature of Mr. Sun. Roughly 97% of all the existing metals on Earth are denser than water, including the peculiar liquid mercury. And among these metals that comprise that 97%, osmium is the most compact with a density of 22 grams per centimeter cube. Next is conductivity. Metals are known to be good conductors of both heat and electricity. This is the reason why these elements are commonly used as wires. And the best conductor? It's none other than silver. Yes, silver. But we don't often see shining shimmering silver wires around us, right? It is because silver is too expensive for common use. Thanks to copper and aluminum, we can have less expensive but highly conductive electrical wires. Property number 5 is malleability, the object's ability to be hammered into thin sheets. In the case of metals, well, they're all malleable. And the most malleable of all is everyone's favorite, gold. Last is ductility, the ability of an object to be stretched into wires without breaking. Just like all metals, platinum is also ductile. It is even considered as the most ductile metal. Commonly used metals. First is element 13, aluminum or aluminium. Aluminum is a strong yet lightweight metal that is commonly found in soda cans, foils, and kitchen utensils. Second is titanium. Titanium often combines with other metals to form alloys, and these alloys are commonly used in aircraft, spacecraft, and missiles. Moreover, due to the non-allergenic property and immunity to attack from body fluids, this metal is often used in implant devices. The next metal is copper, which is commonly used in electrical equipment, specifically in wires and motors. Iron, on one hand, is considered as one of the busiest elements in sustaining life on Earth. Why? Because it does not only form steel by combining with carbon, it also serves as the main component of hemoglobin, the pigment in red blood cells which is responsible for carrying oxygen to different parts of the body. Are you familiar with tin cans? Tin is the star element there. It coats steel to prevent the can from corroding. Aside from that, it is also used in solders and bearings. Meanwhile, lead is used in car batteries, paint pigments, and weights for lifting. Lead is also a component of aprons used in medical facilities to protect workers and patients from radiation such as X-rays and gamma rays. Another electromagnetic radiation is visible light, the only radiation visible to the naked eye. One thing that emits visible light is a firework. Fireworks are capable of showing a colorful light display on a dark, dreamy sky thanks to the metals listed here. Time for the non-metals. Non-metal is an element that lacks the physical and chemical properties of a metal. In simple terms, non-metal is a direct contrast of a metal. Because of this, non-metals are non-lustrous, non-malleable, non-ductile, and non-conductive. They also have low density, melting, and boiling points. Monoatomic gaseous nonmetals are elements that exist in nature as stable individual atoms. It only means that they do not rely on other atoms to have a stable existence. The 7 monoatomic nonmetals are helium, neon, argon, krypton, xenon, radon, and the last element in the periodic table, oganesson. Nonmetals can also exist in nature as diatomic molecules. Diatomic molecules exist as a combination of two elements of the same type. The 7 diatomic molecules are hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine, the only liquid nonmetal. Commonly used nonmetals. Element 1, hydrogen, is the most abundant element in the universe. It is often used in making margarine, fuel in rockets, welding, and in producing hydrochloric acid, which is the acid present in our stomachs. Also, hydrogen forms 2/3 of a molecule of water, or H2O. The remaining 1/3 is composed of an atom of oxygen. Oxygen, specifically oxygen gas or O2, is the second most abundant gas in the atmosphere. This gas is essential in the process of respiration by plants and animals. Without this, all organisms, except many species of bacteria, will not be able to survive. In the industries, oxygen is widely used in therapies, production of steel and methanol, and as a breathing gas in diving and space suits. Next is nitrogen, the most abundant gas in the atmosphere. It makes up about 78% of air. Nitrogen is also used in making fertilizers, nylon, dyes, and explosives. The fourth one is element number 6, carbon. Carbon can take the form of coal, graphite, and diamond. In the form of coal, carbon serves mainly as a fuel. As graphite, it is used for pencil tips, dry cells, and lubricants. And of course, the precious diamond, one of the hardest materials on Earth, is used in jewelry and in cutting and grinding industries. Helium, the lightest of noble gases, is the reason why party balloons float. This is also used in cryogenic applications, welding, and leak detection. Next is neon. Neon glows red-orange when electricity runs through it. For this reason, this noble gas is often used in advertising signs. It is also used in lasers, television tubes, and high-voltage indicators. Number 7 is chlorine. Chlorine can kill bacteria, that is why it is commonly used to treat drinking water and swimming pool water. It is also used to make commercial products such as paper, paint, textiles, and plastics. Last is fluorine, an element capable of preventing dental cavities. For this reason, fluorine becomes an important component of toothpaste and drinking water. The last classification of elements is semi-metal. A semi-metal or a metalloid has properties that are midway between a metal and a non-metal. Generally, semi-metals are lustrous, brittle, have high melting points, and they are semiconductive. Boron, silicon, germanium, arsenic, antimony, tellurium, and polonium are the 7 semi-metals. They are often used in electronics such as cellular phones and laptops. Elements everywhere. That's right, elements are everywhere. But where can I find these elements, you ask? Well, you can find them in both the physical and the natural worlds. They are found in laboratories, rivers, oceans, mountains, the Earth's crust itself, and in the air that we breathe. Even in our body and in the bodies of the organisms around us. These elements are found everywhere. You can also find them in the periodic table of elements, whose father is none other than Dmitri Mendeleev. In the periodic table, we can find a representation of 118 elements, 94 of which are naturally occurring and 24 are synthesized in the laboratories. Among the 118 elements, There are 94 metals, 7 metalloids, and 17 nonmetals. If you are asked to find elements in the periodic table, the first thing that you should do is look for the ladder, the zigzag line, or the Hayes-McDaniel line. This is where the semi-metals are found. On the left side and bottom side of it, you can find the metals. Meanwhile, the nonmetals are found on the right side. Activity time. Questions, clarifications, additional information, comment below. Thank you!